Looking at ray diagrams and sign convention from the chapter Light, Reflection and Refraction from grade 10. First thing that you need to know in this chapter is that there are two types of mirror. Suppose in a spherical mirror, there are two sides, and then the first side is like this. It is curved outwards, whereas the second side, it is curved inwards. The mirror that is curved outwards is called as the convex mirror, and the mirror that is turned inwards is called the concave mirror. So there are two types of mirror, convex mirror and concave mirror. Firstly, we'll be looking at the image formation by a concave mirror for different positions of the object. To understand this concept, you need to know the parts of a mirror. So, in a concave mirror, there are many parts, starting with principal. Principal is the middle of the mirror. This is called the principal or the principal axis of the mirror. We can denote that as P. Next is center of curvature. In the spherical mirror, there should be a center. This center to the concave mirror, this point to the concave mirror is called the center of curvature. Center of curvature. Next is the focus or the focal point. The line or the point in between the principal axis and the center of curvature, that is exactly half, is called as the focal point or focus of the mirror. So there are mainly three parts: principal axis, focus or focal point, as well as center of curvature. Since that is clear, we'll move on to the image formation by a concave mirror. If the position of the object is at infinity, to represent a position at infinity, you draw the object very far from the concave mirror, and it should be like this. So, if the position of the object is at infinity, then the position of the image will be at the focus. So, the ray diagram or the light will get incident on the concave mirror from both the ends like this. Then you draw the parts of the concave mirror: the principal axis, the focus, center of curvature, and the focus over here. Okay, like this. Then the light will get incident on the concave mirror and bend in such a way that it forms at the focus like this. So light gets incident on the concave mirror from the object at infinity. So whenever the object is at infinity, the image will be at the focus. Now, the size of the image will be highly diminished. It will be only a point-sized object, and the nature will be real and inverted. Real and inverted means this image will be like this, whereas virtual and erect will be like this. So this is real and inverted, this is virtual and erect. Now, if the position of the object is beyond C, so what do you mean by beyond C? Beyond C means behind C. So if the object is beyond C, extend the line and draw the object like this, beyond C. Then the position of the image will be between C and F. So how do you draw that? So take the light like this from the object's one end to between C and F. So go like this, like this. Then another image from here itself, this point, like this, in between C and F. So in from C like this. Okay, so one ray from here like this, between C and F like this. Next is from here to here. Most of us draw this like this, but the image should be from here. The first ray should go from the object's one end through the focus like this. Through the focus. The other through the center of curvature. Now if you take the center, this will be in between C and F. You get it? So once again, drawing the diagram, the first ray will go from the top, from focus like this. The second from the center of curvature like this. Now if you take this point, it will be between C and F. So the nature of the image will be real and inverted over here as well. So you draw the image like this, the inverted way. So the object from here, it goes through the focus, and from here through the center of curvature, and it forms in between C and F. So whenever the object is beyond C, the image will be formed between C and F. And the size of the image will be diminished in this diagram. Before it was really point sized, but here it is diminished, which is it is a little more larger than point sized, but still small. Then when the object is at C, so let's take the object at C like this. Then the image also will be at C. So take the ray diagram from here like this, one ray, and take it through the focus like this. Through the focus. Next again through the focus like this. Like this. So like this it goes, the ray goes from here like this. So if you take that point over there, it will be at C. So whenever the object is at C, the image also will be at C. The ray goes through the focus like this, and the image formed will be of the same size. So point sized, then diminished, now here same size, and again the nature will be real and inverted. Now when the object is between C and F, so whenever the object is between C and F like this, the ray will go an incident on the mirror, go through the focus like this. Okay, it goes an incidence on the mirror and goes like this. Next the ray goes again like this, which should be parallel, almost parallel to this line, and see it goes like this, incidence, and comes back. So it goes like this again, and when it goes through the center of curvature like this, and it gets bent, and then at a point they will meet over here. So when they meet, which means it should be over here, the image should be here. So this could only mean that when the object is between C and F, the image will be formed beyond C, that is behind C, over here, beyond C. And the size of the image will be enlarged. See, the object is small, but the size of the image is enlarged, but again the nature is real and inverted. Now whenever the object is at F, or the focal point like this, then let's see where the image will be formed. So again it reflects back through the focus. Again this goes like this. Now this line formed will go through the center of the curvature and extend. It goes on and on and on to infinity. So the image formed when the object is at the focus is at infinity. And again, what about the nature of the image? The nature of the image as well as the size of the image cannot be distinguished, because the image will not be formed as it isn't infinity. Now what about when the object is between the focus and the principal? So when the object is between the focus and the principal, the image is very different from the other images formed. So let's see how it gets formed. So the image or the ray goes an incidence at the principal and it reflects back. So an incident as well as a reflected angle will be formed like this. Okay. Next, another ray will go an incident on this wall, and then it goes again through the center of curvature like this. So once it goes, it goes like this. After it goes, the image will be formed behind the mirror. That is, see, this ray will continue till here, this point, and then this ray, it goes like this. So the image will be behind the mirror. So both the object as well as the image is virtual and erect. When you look here, the image or the nature of the image is virtual and erect, and the size of the image is enlarged. These are the image formations by a concave mirror. What about a convex mirror? So the images formed by the convex mirror are of two types. Whenever the position of the object is at infinity over here, then the rays will be formed like this. So from infinity means dotted lines and then a straight line like this. So the first ray is towards the radius or the circumference of the spherical mirror like this. So the incident ray and the reflected ray. Next, another ray from here to this point, and the incident ray as well as the reflected ray like this. Again, another ray from here all the way here, reflected back. Alright, so this is how the rays from the object at infinity goes towards the convex mirror. Now, the image formed will be at the focus, that is behind the mirror, at the focus. So, extending the reflected ray, it will go like this, all the way like this, and from here as well, like this. So, the image formed from the object at infinity will be at focus, it will be highly diminished or point-sized, and the nature of the image is virtual and erect like this. Next, when the object is between infinity and the pole of the mirror, so extend the line like this all the way there, extend it all the way there, extend it. Then suppose an object is between the principal axis and infinity. It is between infinity and the principal axis. Then what about the image formed? The image formed will be between P and F. So it will be somewhat over here. So the ray diagrams will be, the ray will be gone like this. All the way from here, like this. Then like this. So this is the incident ray. It goes like this. Then the reflected ray like this. Then another image like this over here, and then the reflected ray. So the incident ray, the reflected ray. This ray will get extended all the way to the center of curvature like this, and this one all the way to the focus. Now if you take this point and if you see, it will be between P and F, and again the image formed will be virtual and erect. So whenever the object is between infinity and the principal, then the image formed will be between the principal and the focus. Again, it is behind the mirror. The size is diminished, which means it is a little bit larger than point-sized, and it is virtual and erect. Next, we have the sign convention. So an easy way to remember the sign convention is if you measure everything from the principal axis. So always measure everything from the pole or P. Starting the horizontal sign. So if the object or the image is at the right side, then it will be positive. If it is on the left side, then it will be negative. That's the first rule. So if the object is usually on the left side, so it is always negative, and the image can be either on the left or the right. It depends. Next is the vertical signs. So whenever anything is above the principal axis, then it is positive. And whenever it is below the principal axis, then it is negative. So an easy memory trick to remember is when it is left, negative, right, positive, up, positive, down, negative. Or if you take a graph like this, there are 4 quadrants of a graph. So suppose an object is over here, that is the right side, then it is positive. See, right side, positive. And if the object is to the left side over here, it is negative. And if the object is above the x-axis, then it is positive. Below the x-axis, then negative. The important terms that you need to remember in this lesson is the object distance is represented as u, the image distance is represented as v, and the height is represented as h. So whenever the object is on the left, u is negative. Whenever the object is on the left, u, which is also the object distance, is always negative. And the image, whenever it is on right, the image distance or v is positive. Or whenever the image is on the left, the image distance is always negative. Again, for height, if the height of the image or the object is above the axis, it is always positive, and whenever it is below the axis, it is negative. If this video helped you to understand the ray diagrams as well as the sign convention from the chapter Light, Reflection and Reflection, please like and subscribe to the channel and follow for more videos. And yep, thanks a lot for watching. All the best.